All right, so converting to standard form, we have this function, right? And if we want to convert it to our other forms, there are things we need to know. So first, we should know what our other forms are. We have vertex form as one option, and then we have what we call the factored form. Come on. My computer doesn't like when I upload stuff at the same time as I make a video. It starts losing its tiny mind. So the factored form, this I'm going to put a big asterisk by, not guaranteed to exist. Not every quadratic is factorable. In fact, really only contrived ones will be. But if it is possible, you may have a factored form where you have two things multiplied together, two binomials multiplied together that may or may not have a number out in front. I really shouldn't even call it A because for other two forms, the A is the same and this is something else because you could have, yeah, I would just say that there's some, if you wanted to, I'm trying to think of, I'll just use, oh, this is going to get bad, CX plus D EX plus F. You'd end up with something like that, I guess, as your factored form. Gross. And those don't have to be unique or anything, whatever. Fine. We're going to see factored form. But let's go ahead and work on vertex form because I asked you to do that as completing the square. We already know from the previous question, our vertex is -1, comma, -32. You can use this knowledge. You can know. I'm completely okay with you using that information to already know where the answer is going to be. The A is the same for the vertex form as it is for the standard form, so that 2 is still there. We're going to have an x plus 1 squared minus 32. We know this is the answer. I asked you to use completing the square to get there because this manipulation is important in terms of a calculus skill you will eventually need, and just generally, we could use some practice on our algebra, right? A lot of us, I think, were able to use technology to double check what we were doing in terms of algebra when things were online, and now we need to be able to reason whether or not I'm allowed to do something now that I'm not online. Like, am I still writing the same function or expression as I move from step to step? So the ways we can do this, then there are more than one. The way I did it in class is I decided, okay, I know my goal. My goal is something that looks like that. So I'm going to start with that piece. I'm going to start with the first two terms of my function, thinking about heading there. So I factored the 2 out because I know the A is going to go there. I said, okay, I'm going to factor that 2 out. Leaves me with an x squared plus 2x. And then I shoved the 30 off to the side behind it. Right now I have not changed the function at all. All I have done is factored a 2 out of part of it. And then I said, okay, well, we know from all the beautiful work we were doing with this, those squares when we were doing this in class, that I can make that into a perfect square trinomial. That I could take something like, that I could take that b term if I needed to, divide it in half, and square it and add it to both sides. And as a reminder, if our goal is something that is a perfect square, let me just demonstrate why this is all true, right? If our goal is to come over here, and I'm looking at doing the multiplication of x negative h, x negative h, right? Those two things multiplied together, that this is going to result with an x squared, a negative hx, a negative hx, and a positive h squared. So when you look at this, you actually have pieces of this already in your problem. We don't need an h, right? We have 2x, and I need them, these have to be the same, right? If we look at this, these two, in order for this to be a square, have to match. That's why we take b and divide it by 2. I'm taking this 2x and I'm putting it in both sides of that square. So if I'm thinking about what it is I'm doing to complete this square, I'm starting instead with the actual insides of the box. I'm saying, okay, I have an x squared. I have a 2x. I need to split that. So I put that as an x and an x, right? I could put that as a 1x if I really want to be obvious about it. Those are going to give me back that 2x as that term. And then I could go backwards a little bit. In order for these two to have multiplied together to get x squared, those both must be x. And what do I have to multiply x by to get 1x? Oh, 1. Same thing over here. So this piece that I add has to be a positive 1 because 1 times 1 is positive 1. That is why we're adding a 1 here. That completing the square. So you can memorize negative b squared, I'm sorry, not negative b over 2 squared, or you can really understand why it is we're doing this, why this always results in that perfect square trinomial. Now here is what I did as an extra to show students to sort of justify where I headed. Is at this point, let's just multiply out what we have. We have a 2x squared plus 4x plus 2 minus 30. If I distribute out that 2. If we look back at our original function, because this is supposed to match, I still have a 2x squared, I still have a 4x, I still have the negative 30, but I changed the entire function by adding 2. We're not allowed to change our function from step to step. When we're working with expressions, all we can do is like multiply by 1, add 0. So since I added 2, I've changed my expression, I've changed my function, and I'm in trouble. So this is why we subtracted 2 to make this even. So now I haven't actually changed the expression I started with, I've just made it a little uglier. Now this we're not actually going to do. That is just me showing you why I'm doing the next step. The next step that I was doing in class was taking this 2 and the 1 and multiplying them to figure out what I did to my problem. How did I change it? And then I went ahead and undid that by subtracting 2 on the outside. So I'm going to erase all this other work that I did to sort of prove it to you, hoping that you watching was enough. But I really like when you're doing math, think about how to justify what you're doing. Don't just blindly follow steps. Like if you don't understand why a step is happening, you need to be asking questions of yourself or others. I'm going to kill something because this is not listening to me at all. All right, my video caught up with me. So, or OneNote caught up with me. So now what we would talk about is the final step, which is to just rewrite this. 2 is on the outside. Now the goal is to rewrite that perfect square trinomial as that square. That's what the completing the square is all about. So an x plus 1 squared. And then we'll combine up those back two terms to be a negative 32. So we're back at the same thing we expected to see. Right, I'll just put a y because I'm kind of out of space. This is one method. I really liked, Gianna did a beautiful method on the quiz, so I'm going to show you that as an alternative if you do not like my method, or if it's hard for you to keep track, because a lot of students, they did lose that plus 2 minus 2 thing. They did a minus 1 on the outside. So if you're confused by it, I think Gianna's method will help you. So let's look at Gianna's method really quick, which I saw last year and I completely forgot about. Like I forget about other methods until I see them again. Okay, so here's how Gianna solved that problem. She came in, and when she factored out the 2, she factored it from everything. Not my favorite thing typically because I am a fraction avoider. And if 30 hadn't been divisible by 2, we would have ended up with a fraction, which is why I think I've always gravitated towards the way I do these things. But this doesn't mean it's the only way. So I'm going to show you this alternate. So she factored 2 out of everything. And then did what we normally do. Left the 2 there. Kind of shoved that 15, that minus 15, oops, shoved that minus 15 off a little bit, and she completed the square as usual. So same business we did before. I'm not going to, relitigate why we added the 1. And then she subtracted the 1. And then she went, okay, well, this has the 2 pieces that I want. Part of this is the piece I care about, that this part, right? That ax, the a times x minus h squared. And part of it is extra crap that I don't need for my perfect square. So she broke it apart. She said, okay, cool. So this is 2x plus 1 squared. Cool, that's that first piece. We knew that. We've been there, done this now 3 different ways. And then she said, okay, well, but the other piece still has the 2. But it's a negative 16 that's inside of there, right? If I combine those 2 pieces up, those 2 constants that I didn't really need for my perfect square trinomial, there's that 16. I just cannot forget that the 2 was actually applied to all of them. So a different place to make a mistake, but still very cute, very clever. We can rewrite this with our final version by just multiplying out the 2 and the negative 16 to get our negative 32. So our third way to sort of get to this answer. Both of these methods here are completing the square. Slightly different in terms of how that completing the square happens, but those are completing the square. Just finding the vertex using the vertex shortcut and rewriting it in vertex form might get you in trouble when you get into calculus and you're trying to complete the square to take some integrals. So this is what I was hoping to see on the quiz.